Today's lesson is on simple harmonic motion, log page 5 in your logbook. Some examples of simple harmonic motion are a swinging pendulum, the vibrations of a tuning fork, and the weight on a coiled spring. The picture that I have here is a picture of a swinging pendulum. If you look at point B, that's the rest position or the point of equilibrium. If my pendulum was hanging at rest, it was still, then it would hang straight down at point B. If I took that pendulum and pulled it back to point A, the distance that I have pulled it is now the amplitude. I could have also pulled it to the right and pulled it over to point C. The distance there would still be the amplitude. The amount of time that it takes, if I pull the pendulum back to point A and I let it go, it'll swing through B over to C, back through B, and back towards A. Once it reaches A or close to it, the time that it takes for it to go through that one swing is the period. Let's write those two things down. The amplitude of a vibration is the distance from the equilibrium position, remember that's point B, to its point of greatest displacement. That's either A or C. That distance is the amplitude. Since amplitude is equal to a distance, it's always going to be positive. The period of a vibrating object is the time required to complete one vibration. It's the amount of time. So the period is an amount of time. You should highlight that. It's the amount of time that it takes to go through one complete vibration. That means from point A through B, over to C, and back to A. The theorem for simple harmonic motion says that if I have an object that moves on a coordinate plane or a coordinate axis so that its distance d from the origin at time t is given by either of these formulas. The distance is equal to a times the cosine of omega t, where d is distance and t is time, or d is equal to a sine omega t. A and omega are both greater than 0 and they're both constant. If this is the case, then this object moves with simple harmonic motion. The motion always has an amplitude of an amplitude of the absolute value of A, because remember, amplitude always has to be positive, and a period of 2 pi divided by omega. The frequency, F, of an object in simple harmonic motion is the number of oscillations per unit of time. How many times does it go through that oscillation in 1 second or in 1 minute, depending on what your unit of time is? Therefore, the frequency is just omega divided by 2 pi, which is just the reciprocal of the period. So the frequency is simply the reciprocal of the period. If you know the period, you know the frequency. If you know the frequency, you also know the period. Please note that omega here has to also be positive. So let's look at an example. Suppose an object is attached to a pendulum and is pulled a distance of 7 meters to the left from its rest position and then released. If the time for one oscillation is 4 seconds, write an equation that relates the distance d of the object from its rest position after time t in seconds. And we're going to assume no friction. When they say assume no friction, that tells me I'm going to be using simple harmonic motion. And when we're writing equations, we're always going to use the cosine formula because it's easier. And I'm off the paper, sorry. So always use the cosine formula when it asks you to write an equation. When we get to chapter 5, I'll explain more why we do this. But for right now, if you'll just be sure you use the cosine formula whenever it says to write an equation. Okay, so let's see what we know. We have pulled this object a distance of 7 meters to the left. So that means that A is going to be negative 7 because we moved it 7 meters to the left. The negative is because we went left. If we had pulled it to the right, we would put positive 7. From this, if we wanted to know our amplitude, we could find it because the amplitude is always the absolute value of A, which in this case would be the absolute value of negative 7, which is 7. However, A is what we're going to use in our formula because it's not the absolute value of A here, it's just A. The other thing that we need to see, and I did that and didn't even let you see it, I apologize. Okay, the other thing that we need to see here is what omega is. Omega, okay, we know that we need omega for our formula, but we don't have omega in the problem. However, they do tell us what the period is. They tell us that the period, and I'm going to move back over again, we know that the period is 4 seconds. We also know a formula for the period, which is 2 pi divided by omega. 2 pi divided by omega. Well, if we could solve this for omega, then we'll have our information. So I'm going to multiply both sides of this equation by omega so that these omegas cancel, and I get 4 omega is equal to 2 pi. Divide by 4 to solve for omega, and omega is equal to 2 pi over 4, which will simplify to pi over 2. Now, since I know what my omega is, and I know what my A is, I can simply come back to my formula and substitute those in and write the equation. D is equal to A, which is negative 7, times the cosine of omega, which is pi over 2, times T. And I have done exactly what they asked me to do. I've written the simple harmonic motion formula for this object. Let's look at another example. Because you know, in algebra and in math, they always want you to go in both directions. Suppose that the distance d in centimeters an object travels in time t in seconds satisfies the equation d equals negative 15 sine 4t. In this problem, they want us to do several things. They have given us the formula. Sometimes when they give you a formula, they are going to give you the sine formula. When you're writing the equation, when you're asked to write the equation, always use cosine. So letter A asks us to describe the motion of the object. Well, because this is of the form d equals a sine omega t, I know this is simple harmonic motion. Letter B asks me, what is the maximum displacement from its resting position? I know that when they ask me for the maximum displacement, they're asking me for a distance, which is the amplitude, and I know that's going to be the absolute value of whatever A is. So the amplitude, which is the maximum displacement from rest, is going to be the absolute value of negative 15, which would be 15 centimeters. I know this is in centimeters because the problem tells me that my distance here is in centimeters. Letter C. Let me slide this up just a touch. Letter C says, what is the time required for one oscillation? Well, I know the time required for one oscillation is the period. I know the formula for the period is 2 pi divided by omega. So I know then that the period here is 2 pi divided by omega, which in this particular problem is 4. So the period is pi over 2. Now, the period is the amount of time for one oscillation. So this is seconds, and if you wanted to put per one oscillation, you don't have to put one oscillation, but this is pi over 2 seconds for one oscillation. If you label it this way to begin with for a little while, it may help you to understand frequency a little bit better. Okay, letter D, I'm going to put right up here. Letter D says, what is the frequency? Well, frequency, I know, is just the reciprocal of the period. The reciprocal, slide. The reciprocal of the period. Okay, and remember that period is just t. So if t is pi over 2, and that's seconds per oscillation, then the frequency is simply 2 divided by pi, and that would be oscillations per second. And that's really all there is to simple harmonic motion.